2.7 is called Investigating Graphs of Polynomial Functions. We're going to use properties of what is called end behavior to analyze and describe functions. We are going to graph polynomial functions without a calculator, and then we're also going to find what is called maxima and minima. Okay, do any of you know what end behavior of a graph is? I don't expect you to. I know it's a term that probably hasn't been used before. But when you have a graph, you don't have to draw this. I'm just going to show you some examples here. Okay, if you draw a polynomial graph, maybe it looks something like this. Okay, the end behavior is just literally what are the ends of the graph doing. Okay, that's what you're going to describe. Okay, and when you describe it, we're going to use special terms.
But how does the graph have an end? I thought they're like endless.
Oh, yeah. So it's stretching to infinity. Yep. So what is happening is when you're describing it, you're just saying, is it going up or is it going down?
Oh, okay.
And we're actually going to be using the infinity symbols to help us with that. So when you're describing the end behavior, okay, what it's talking about is where each end of the graph is going. Let me block this out. Okay, and then that is going to be an up-down type of answer. Okay, so where each end of the graph is going. Okay, is it going up or is it going down? Okay, because sometimes we have graphs like this, right? Sometimes it's going up on both sides. The other thing that we look at when we're describing end behavior is each side of the graph. So every single graph has a right side and it has a left side. Has a right side and has a left side. Okay, so the other thing we do with end behavior is we talk about it in terms of the left and right. So there are two sides to every graph, the left and the right. Okay, so you have the right end, this one is going up. You have the left end, this one's going down. This is a good old parabola here, where the right end and the left end are both going up. Okay, so you can draw these two examples, or if you want to draw those two, that's fine. Okay, so draw some graphs. Whatever I write down, you should write down. Okay, so by end behavior, we're talking about where each end of the graph is going. Is it going up, down? And then what's happening on the left side and the right side. Alright, so what we do is we are going to use positive infinity and negative infinity to represent the end behavior. So we have positive infinity and negative infinity to represent end behavior. Okay? Now, these symbols mean two different things, right? You know how we have words in English that mean two different things? Like cool. What can cool mean? Yeah, it can mean temperature-wise, that you're cold, right? Or it can mean that you're totally awesome. Okay, so these symbols represent two things. Oh, and you guys are going to I know sometimes when you first do the infinity sign, it can look a little wonky. You'll get it with practice. It's just a figure 8, okay? So start here. Okay, and then if you want to do like two ovals next to each other, that's fine. So positive infinity represents right. So positive infinity represents right or up. Okay, so positive infinity can mean right or up. Okay, and then we have a negative infinity. Okay, and negative infinity represents left. Represents left or down. Okay, so when we are writing out, we're eventually going to write out these statements, and we want to know what happens on the left and the right sides of the graph. Okay, and when we say we want to know what happens, in particular, what we want to know is if the graph is rising, which means it's going up, or if it's falling. Okay, is it going down? Is it rising or is it falling? Okay, so if we want to say what happens on the left side of the graph, what we write is x goes to negative infinity. X goes to negative infinity. Okay, and let's think about why that makes sense. I'm just going to draw a little grid here. Okay, so I have the y and I have the x. Okay, so the x-axis runs from left to right, correct? So on the left side, our values keep going down. They keep going to negative infinity. That's why this makes sense. You use the x-axis. Okay, you're going to use x for left and right. Okay, because that's where the x-axis goes. It goes left and right. So you have the left side and then you have the right side. Okay, so this says similarly for the right side of the graph, we're going to write x goes to positive infinity. Okay, because on the right side we're going to positive infinity there. Okay, so we said we want to know what happens on the left and right. This is how we're going to use these, but we also want to know if it's going up or down. So if the end is rising or going up, what we would say is, and this is interchangeable, so sometimes we say y Other times you'll see like you'll see p of x or whatever the function is. Okay, and that makes sense because for y, if you are going up, you are going to positive infinity, and if you are going down, you are going to negative infinity. So again, that makes sense with our axes. And then if the end is falling or going downward, we say y goes to negative infinity. Okay, and you can use y, p of x, f of x, okay, for the up and the down. And I'll show you that with specific examples. So sometimes it'll say like your p of x or your f of x, so all of those are interchangeable. Okay, just like with the y equals, sometimes we have f of x equals, that'll be the same. Okay, so how do we figure out the end behavior of a graph? Okay, so how do we figure that out? Well, there are two things we can use to figure it out without even graphing. You can just look at the equation and then you can figure out where it's going, okay? So you can use the degree of the equation, okay? Use the degree of the polynomial and leading coefficient. Okay, the leading coefficient and the degree are what determine its end behavior. So with the degree, you want to look and see if it's even or odd. Okay? If the degree is odd, then the ends go in opposite directions. Okay, if the degree is even, okay, if the degree is even, then the ends go in the same direction. Okay, so if the degree is odd, they go in opposite directions. If the degree is even, they go in the same direction. And I always remember that because the ODD and the OPP, those feel like they fit together for me. You can think like, oh yeah, they both start with O, right? Opposite and odd. Okay, the other thing you have to look out for is the leading coefficient. So if the leading coefficient is positive, okay, then the graph rises on the right side of the graph. And then if the leading coefficient is negative, then the graph falls on the right. Okay, so one thing I want you to notice here is that the leading coefficient, the LCO, always tells you about the right side. It always tells you about the right side. That doesn't change. With a lot of these, you're doing the opposite, right? So if it's on the left and then it's on the right, it's up and then it's down. So it's easy to think, oh yeah, if it rises, it's on the right, and if it falls, it's on the left. No. The leading coefficient is always going to tell you what happens on that right side. Okay, so it's always on the right side. Okay? Alright, what we're going to do next is look at this chart. So right now, this chart is probably a little confusing, and it seems like there's a bunch of symbols. Okay, you are going to be writing those statements. Okay, the statements that you see here and here, you're going to be writing those out. So what we're going to do is we're going to annotate them, and then we're going to come up with something that you can use whenever you're describing the M behavior. Okay, so if you're asked to describe the M behavior, you will be writing a statement like in this chart. Okay, so it says if P of X has, and the first thing it talks about is the leading coefficient. A is greater than 0, which means if A is greater than 0, the leading coefficient is what? Yeah, positive. Okay, so let's see what happens if it is positive. Okay, so it says as x goes to positive infinity. Now, I know from what we just talked about that the x-axis runs left and right. So for the x value, if it's going to positive infinity, okay, that means that they are talking about the right side of the graph. And here it says P of x goes to positive infinity. So if they say P of x, right, or y, or f of x, that means up. So this statement, as x goes to positive infinity, P of x goes to positive infinity, means on the right side of the graph, it is going upward. Okay, and the bottom, it says as x goes to negative infinity. So that means on the left side of the graph, it says P of x goes to negative infinity, that means it's going down. Okay, so on the left side, you are going down. Okay, notice that this is for an odd degree. So if the degree is odd, they go in opposite directions. Okay, so that graph fits it. And then if it is an even degree, let's look and see what happens. Okay, if it is an even degree, as x goes to negative infinity, so because it's x, it's left or right, so this means left. P of x goes to positive infinity, so that means up. Okay, so on the left side of the graph, it is going up. So that is this part of the graph. Okay, here this says as x goes to positive infinity, so it's x, which means it's talking about the right. P of x goes to positive infinity, because it's P of x, it means it's going up. Okay, do you guys think that you could notate this one, or do you want to do one more together? What do you think? Want to give it a try? Okay, and this is where your leading coefficient is negative. Leading coefficient is less than 0. Okay, Jack, what do you think? What does this mean? As x goes to negative infinity. Yes, great. Okay, and then Ashay, what about P of x goes to positive infinity?
Going right.
No?
Oh, up.
Yes. Okay, and then it's because it's the P of x and not just the x. Alright, and then as x goes to positive infinity, Julianne, what's that going to be, you think? Yep. Okay, and then Ava, what about this one? P of x goes to negative infinity. What does that mean?
Going down.
Yeah. Good. All right, let's do the last one. Some of you already do the last one? Most of you already do it? All right, Sam, help me with this one. As x goes to negative infinity, what does that mean? Good. Rashawn, what about this one? Good. Okay, so this one will be down. And then Dylan, what about this one? As x goes to positive infinity, what happens? What does that mean? Yeah? Okay, and then Dane, as p of x goes to negative infinity, what does that mean? Yes. All right, now there's one more thing that I want you guys to notice about these. In every single box, you have x goes to positive and x goes to negative infinity. X goes to negative, x goes to positive. X goes to negative, x goes to positive. Okay, but the p of x does not always have to have the opposites. The reason why is because you need to say what is happening on both sides of the graph. So in general, when you are asked to identify the end behavior, you can use this and just fill in the blanks. So you always want to know what happens on the left side and then you always want to know what happens on the right side. Okay, so in general, you can say as x goes to negative infinity, what does p of x do? As x goes to positive infinity, what does p of x do? Okay, because then what you're saying is this is what happens on the left side, this is what happens on the right side. Now, to determine where it's going, okay, we are going to learn how to fill these in. Okay, so we're going to fill in the blanks based on the degree and the leading coefficient. Okay, and that's what we're going to do on the next page. So we're going to use the degree and the leading coefficient to make those statements.